Okay, hi everyone. Welcome to Science at Home. And today we have Tolis with us, who is a researcher at the at the Observatory. So we're going to ask you a few questions, Tolis, just about how you got to Armagh and everything like that. So I'll start right in. That is the first question. Where are you from and how did you get to be in Armagh?
Right. Oh, okay. So first of all, I'd like to thank you, Anna, for inviting me for this interview, and
no problem.
Hopefully this will be of some interest to our viewers. So, where did I come from? Well, okay, I didn't come from an egg. I suppose I'm a regular human being. I was born in Greece. I grew up in Greece. And at some point, I decided to move to the UK. Well, I did my PhD in London. I spent 5 very nice years in London. And after a couple of postdocs, so that is short research work contracts that one usually takes after the PhD. And I decided to come to Armagh, and I've been at the observatory now for almost 20 years.
Brilliant. What attracted you to Armagh? What attracted you to Armagh in the first place?
Well, for one thing, Armagh had a reputation and still has a reputation for work on the solar system, and presumably we're going to get into that later on. But that's one of the things that made me think about seriously coming to Armagh. And of course, the work description focuses on research. So if you ask any scientist, if they'd like to work, primarily, spend most of the time on research, they'll they just say yes right away. So,
yeah.
It's a no-brainer almost.
Well, that's good. So, can you explain the type of research you do then?
All right. So, okay. So I've said before that I was attracted by the solar system work that was done in Armagh, and it has still done. Hopefully, contribute to the reputation of the observatory, as a place to do solar system work. But anyway, well, of course, a fundamental question in science is that where does the universe come from? Why are things the way that they are? And different people choose their own chunk of the universe to investigate. Well, for reasons that have to do with their life experience, the character, and so on. So I chose the solar system. So there are plenty of planets, satellites, asteroids, and comets out there, and I want to find out where they all came from. They didn't just materialized. They were created by physical processes.
Yeah.
Yes, and so what we see now should tell us of how the solar system was in the past, if only we can understand how the solar system changed over time. So
that's great. I'm sure a lot of people are interested in that, and you get to do it every day.
Indeed, even weekends.
Oh, brilliant. Well, brilliant or not so brilliant, depending on your point of view.
Only if you want to.
Yeah. Okay.
It's not mandatory.
So the traditional image people have of astronomers then is someone sitting at a telescope. Do you use telescopes in your research?
Okay. Well, the answer is yes. I have used telescopes. I should say, well, it's probably more correct to say that I've used data from many kinds of telescopes, and I've used the telescopes in many different ways. So, for example, many observations these days are done by what they call surveys. So these surveys are, for the most part, automated, so there's no human involvement, and the only job that remains to the person who wants to do the research is actually looking at the data and decide which part of it they're interested in. Occasionally, well, some people do this more often than others, but occasionally you want to collect some data for a specific project, right? So now this data may already be lying in a survey database. Well, that's not certain. So you look, and if you find it there, so much the better. If you don't, you have to write a proposal.
Okay.
With the telescope time to make the observations that you need.
Okay.
Right. So you write the proposal, you wait a few months, and if you're successful, then you could actually physically travel to the telescope to do the observations by yourself.
Brilliant.
But
That would be exciting.
most of the time, that's not necessary.
Okay.
Because the professional telescopes these days are run by consortia, and consortia can hire engineers to take up the technical work of operating and maintaining the telescopes. But I do know many astronomers who regularly go to the telescope because, of course, even though the technician on site would know how to work the telescope, you are the only expert on your own project, right?
Yeah.
So you have to really sort of fine-tune the observations, sometimes at real time, to make sure that you get what you've what you hope to achieve. Because don't forget, traveling to a telescope these days is not trivial, and I don't mean because of COVID. It was always not trivial. You have to go to a faraway place. You have to climb up a mountain where sometimes there's not enough oxygen to breathe properly.
Ooh,
right?
wow.
Yes, and you have to stay there for several nights. All right, sometimes night after night. So it can be exhausting.
Yeah.
So you have to put some effort in planning this properly. Covering the different contingencies and so on. Because at the end of the day, if you don't get the data, you have to write another proposal to do it again.
Do it all over again.
Exactly. And yeah, of course, it's fun also. I mean, there's a novelty factor involved. Yes, because
it does sound fun, but also difficult.
Yes.
Yeah, tricky. So what's the most difficult part of your research been?
Okay. Well, I would say that it's not the research. It's not the research part. All of the traveling to telescopes. I, I would say it's time management.
Okay.
It actually how to handle the different, like duties that you have to do in, as a researcher in the 21st century. And this includes, apart from actually doing the research, you have to do some reporting that goes with the research, because your funder has to know that you're doing what you're supposed to be doing.
Yeah.
And occasionally you have to supervise students, PhD students. You have to write proposals. And this balance is not constant, but it's really a dynamic process.
Yeah.
Projects come and go, and there could be, for example, circumstances when you need, for example, to respond quickly to a new situation. For example, when what can I tell you? When a new type of object is discovered, like a couple of years ago, astronomers picked up an object that came from outside the solar system.
Yeah.
What happened then? The community really had to rush to put in observing proposals to take measurements of the object before it disappeared back into interstellar space.
Yeah.
Right? So that means that sometimes you have to drop whatever you're doing and just do something very specific.
Just react. Yeah.
Yes. Yeah. And of course the trick is to know when to react and when not to.
Yeah, that does sound tricky. Well, it may sound tricky, but you also seem to love what you do. So have you always loved astronomy? Have you always wanted to do it, or did it come to you later in life?
Well, for better or for worse, I have to admit that I cannot remember a time when I was not interested in astronomy. I think the earliest time I can remember me thinking about becoming an astronomer was about when I was about 10. But then at some point I asked my mom about that. Said, "Was that when I was interested, Mom?" And she said, "No, you actually asked your uncle to buy you a telescope when you were 8 years old. So there you go." So the answer to your question is basically yes.
Lifelong interest. That's brilliant.
You can say that.
All right, so you've mentioned going to different telescopes and things like that, and I know that when you're doing research, you can also head to different conferences all over the world.
That's right.
So where's the coolest or most unusual place you've ever been for your research?
Right. So, okay. Well, I have two answers to that question, and the second one is slightly heretic. But I'll start with the first one. I think, suppose the most unusual place is also the highest place I've ever been on Earth without actually going into an airplane. And this is about 10 years ago. I went to this meeting, and it was held in May in a ski resort in Colorado.
Okay.
So it was the end of the snow season, so I suppose the organizers got a good deal, because otherwise, the ski resort would have been empty. So,
Yeah.
attitude of 9,000 feet. And I do distinctly remember panting when going up the stairs. And also the other thing that you have to be careful with high places, that it's easy to get zapped by static electricity because the atmosphere is so dry. So I got zapped a couple of times by the banister in the stairs. So yeah, well, this is, I would say, the most unusual place that I've been to physically, which now brings me to the second part of my answer. But really, the most unusual places an astronomer can go to is the places that go with their imagination. So, of course, 99.99% of us will never travel in space or in time, for that matter, but we can go there with our heads.
Yeah.
Being astronomers, we have a good idea about what to expect. For example, when you sit when you stand on another celestial body. So what actually I would most like to do, what I've occasionally imagine I could do, is stargazing from other planets. So, for example, Mars. So that would be a good experience.
You have no trouble with light pollution there?
No, there's no light pollution, and also there's actually much less interference from the moon. So of course, Mars has two small moons, but they're not very bright when seen from the surface. So there wouldn't be much trouble. You can observe. You can probably be able to, to observe under a dark sky essentially all the time, except, for example, when there's a dust storm in progress.
Yeah.
Mars has its hazards too, and one of them is that occasionally winds lift dust up in the atmosphere, and the atmosphere becomes very opaque or very thick, and it's very difficult to see anything, even the sun. So different
sky, different weather and everything like that.
That's right, but it still is more exciting than going to an object without air. Or of course you get perfect skies, but of course, yeah,
can't survive. But apart from that, great. Okay, so we're nearly at the end of this little interview. But just before we go, I would like to ask you, why should more people consider science for their future career?
Okay. I don't think that there's a single answer to this question, because people are different, and secondly, I think science is something that has to be experienced before someone can decide for themselves if this is what they want to do for the rest of their lives, or for a big chunk of the professional lives. But what I would say, it's worth trying it out. The reason I say that, because you see, science has this empowering quality. It's the art of working things out for yourself, evaluating data, testing hypotheses, making decisions, and as people, we do these things all the time. So in a sense, all of us are scientists because we go through the same process. For example, when, for example, we see something on Facebook and we try to decide whether it's real or fake. Or, for instance, when we try to buy a house, where you have to do your research, you have to talk to your estate agent and decide how much of what she says to you you can believe, and then ultimately you have to make a decision.
Yeah.
So in a sense, we're all scientists, but you see, science is like a muscle that you have to train. Otherwise, it atrophies. So it's like driving. That the more you do it, the better you get at it. So getting trained as a scientist actually builds up that muscle. So basically, you build up your, if you like, your mental biceps. You know. So I think, well, I can't see why people would not want to have this, you know, to have this special superpower, if you like, to, you know, being able to work things out. Given an amount of data and making some decisions, because at the end it's better for them, for themselves. Yeah, if you make a more informed decision and if you know the pitfalls, if you're trying to recognize the pitfalls, then you improve your own life. So
that's a really interesting perspective on it.
I would say people should try science, and if they find that it's not for them, at least in the first few decades of their lives, there's still time to make a course correction. So.
Oh yeah, absolutely. Well, thank you very much for coming and talking to me today, Tolis.
Well, thank you, Anna. Yeah.
I've really enjoyed listening to your experience and everything like that. Well, so I'm gonna say bye, everyone. Come again to Science at Home. We'll have more astronomers on, and we might even have Tolis again if he's willing to answer a few questions about astronomy. But thank you very much, everyone, and stay safe.